So to start, let's just go with the main deck here. So we'll start meshing the main deck. And let me make that my main window here. You can just double click on any one of these windows if you want to quickly zoom it up to full size. So there were a couple of scripts that were created, and most of these scripts are proof of concept. So they could use some additional debugging. They were mainly created to see what we could speed up, and eventually they would get more polished to be more production ready. But they've been useful in the past, but we just caution people that if you have an issue with them or something, please let us know. They were developed in Rhino 5 rather than Rhino 6 here, and you're using Rhino 7, so there could be some changes that occurred in between those versions that might break something in there. So if you do find something, please let us know so we can fix it. Let me start off with the first one. Now, there's a couple methods for creating all of these section cuts that we're going to want. We need a collection of nodes for our mesh, and those nodes have to represent the intersections of all of our bulkheads with our decks and shell plating, as well as the locations of any stiffeners, frames, girders, and so forth, so that we can put the beam traces on the appropriate spots in the mesh. Now, typically, we know all of our frames are going to be running transversely, so we're going to need some nice transverse cuts along the length to define our mesh. Our stiffener traces, at least on the decks, are most likely going to be pretty much parallel to the center line. So we'd wind up with a pretty rectangular mesh, and it should be nice and easy to make those cuts through the surface to find all of the mesh intersection points. Where we get some differences there are when you're dealing with the hull, the shell plating, where the flare in the hull can change the girth from the vertical sides at midships to something with a significant amount of flare up at the bow. You might have 30 degrees of flare up there, and that's going to greatly affect the length of that section going from the second deck to the main deck. It might be significantly longer up at the bow, so that if you have a standard stiffener spacing, let's say you only have 5 stiffeners at midships here, you might have 8 or 9 up at the bow. So those need to appear at some point along the hull here. So we don't necessarily want just flat planar cuts through there. You might want an even girth along the length. And that's what one of these scripts will do. For generating that rectangular grid along the length of the hull and transversely, one thing I originally did was to create cutting planes. And in fact, I think they're even in here if on a hidden layer. So if we turn on the mesh layer and I click on to display selected objects, yes, you can see that this is a collection of cutting planes that I had created to make the cuts along the length of the hull. Now the mesh we're creating is on 1 meter increments along the length, as well as 1 meter increments transversely. But you'll notice there are a couple of bulkheads in there. Let me turn off that mesh. We've got a bulkhead at this location and this location. Now this one is at 10 meters, so that one lines up nicely with our 1 meter spacing. This bulkhead, however, if we click the single point button and we can just hover over this to find the location, you can see in the lower left here, the X, Y, and Z locations when I hover there are 60 meters, but it's 8.375 meters off center line. So that doesn't fall on one of our nice 1 meter increments. So depending on what the structural drawings call for, I mean, we're going to want to create nodes at every location where we have a stiffener. So we're going to assume that our structural drawing for the deck says there is a stiffener at 1 meter increments, and this bulkhead will land in between stiffeners. If you look at the mesh that was created previously, you can see it's not quite uniform spacing. If we were to, let me turn off the surfaces there. If we take a single point there, or if you want under the Analyze menu, you have an option for length or distance. Length will measure the length of any line that you click on. It'll give you the total length. Or distance, you simply pick 2 points. So you can see vertex to vertex here, it was a 1 meter spacing, and that's true for the first 5 meters. So the first 5 in there are all 1 meter increments, but then we switch over to 0.84, and it's actually 0.84375. So essentially, the next 5 meters, because we have a bulkhead at 10 in that area, that bulkhead is at 10 meters. This one is at 8.375. So the spacing that we selected, and we put this on every deck so that our transverse bulkheads would have vertical lines for our stiffeners on the transverse bulkhead. The spacing changes from 1 meter increments to 4 evenly spaced increments, getting out to 8.375, and then 2 at 0.8125, and then back to 1 meter increments. So since we're not using that for our stiffener spacing on here, we'll stick with 1 meters, and we'll just accommodate that one bulkhead that's at an odd spacing. So it'll be a little different than the mesh that you see in the sample file here. So to create that, we could either do a series of cutting planes like what I showed there, and to create those, you would simply go into like surface, plane, and the easy way to create a plane here is corner to corner, which is just click one point and then go to the opposite corner, click another one, make sure it encompasses the entire hull, and it created it at the construction plane, which is at x equals 0. And then I could grab that and use the array command and do a rectangular array with 161 in the x direction, 1 in y, 1 in z, with a 1 meter spacing. And I started that command in the right-hand view, so I should have executed that command from the front, because I guess x in that view was different. It took x on the construction plane rather than the global x. So if I do 161 in x, 1 meter, you can see you can quickly create that series of cutting planes. And then we can do intersections between two groups. When you want to intersect two objects, you have a couple of options here. You can select two objects, like say this deck and this bulkhead. And if I go under curve, there is an option to do an intersection, which will intersect all of the selected objects. So if I had this bulkhead, 2 decks, and the side shell, it would find all intersections between all of them. But a lot of times you want to intersect 2 groups of objects rather than every possible intersection. Like if I selected the deck, both decks in the bulkhead and the side shell, I might only be intending to find the curves at this transverse bulkhead. But because I have decks and the side shell selected, it would also find for the decked edge of the main deck as well as the outer edge of the second deck, because those surfaces are selected. If I wanted to restrict it here, I could do intersection of 2 sets. And they have that option here where I could select just that single transverse frame with multiple longitudinal surfaces, and I would only get the intersections at the transverse bulkhead. It would ignore the intersections that were all from within the same set of objects. So that can come in handy when you're doing some of these intersections. For now, rather than creating all of those cutting planes, which is a lot of extra geometry, makes it difficult to see into the model, I tend to like using the contour command. Now, one advantage of using those planes and doing a manual intersection is that you have very good control over the spacing. So for that transverse spacing, if I actually did need 5 increments at 1 meter, then 4 increments at 0.844, and then 2 at 0.8125, and then a couple more at 1 meter, using those planes might be a good option. A little bit extra work, but you have very good control. If you have regular spacing, there's a command called contour, which works really, really well and quickly for doing these things. So if you type in contour, it essentially is doing the same thing. It's creating a series of parallel sections and cutting them through whatever object you tell it in a given direction. So we type contour, select objects to do the contour command on. So I'll do the main deck. Now you need a base point, and that'll set, where one of the section cuts is going to be. So I'll use the origin. I'll just type in 0, 0, and then the direction. So I want this to be in the longitudinal direction. And remember, I have orthogonal still turned on. So when I drag down here, you can see in the other views, it's right along the x-axis. and then it wants a distance between contours, and it's already set to 1, but I can type in 1 meter. And it very quickly marches down the object and slices all of those curves. So now I have all of these curves in there. Now again, I'm still on my surfaces layer, so it created all of these surfaces. So let me create a new one here, and eventually we'll call this one mesh, but just leave it layer 1 for now. And I'm going to move it down to the bottom below strakes. We'll call this mesh 2. And I'll do select curves to grab them all. Go into the properties window, simply move them to my mesh 2 layer. And I'll make that current. So any new items that I create are going to be created on mesh 2. And I turn off surfaces and I still see my curves there. So now I have all of the transverse cuts for where I need nodes on my mesh, although I still need one back here. And you'll see we just had a point at the bow, so we'll need to accommodate that later. Now there's a couple ways I can create the meshes here. One, I could use select curves to create or to select all of the curves in the model. Since I know I only have those curves on the mesh 2 layer right now, I could say select objects and it'll select all the objects. But now I have all these curves selected, and there are, I guess, 3 ways that you can create the nodes that we want. So one method would be to use the contour command again. Except this time I'll start on center line and go out. And then I give it a distance again, and it would be 1 meters because I want 1 meters in both directions. And it'll cut contours through those lines, which results in points. So now I have a large collection of points defining my surface. Now I'm going to undo that now to do one of the other options. There is a script that will create the mesh for you based on a collection of curves. So if I select all these curves and then run another script, and we go into Tools, Rhino Script, Load, and this is the curves to mesh specific spacing. And you can find this one also in the models and samples, Rhino scripts. There is curves to mesh specific spacing. So I already have this loaded in here. I'll click on it and I'll say load. Now, I already pre-selected all the curves, so it skips the step of asking me for which curves I want to run and goes straight to what spacing do you want. By default, it uses a 1/4 meter. I'm going to make that 1 meter. And then it asks for a tolerance for distance between points. When it goes to create points along this curve, these curves are not all in increments of 1 meter in terms of total length. So there's going to be a little leftover at the end. So this tolerance is what do I do with the leftover? And basically it's saying that if that last point is less than 10% of my spacing, don't bother adding an extra point, just make the last segment a little longer. Basically the last segment on the curve can be up to 10% larger than the selected spacing. If it's any larger than 10%, then go ahead and put another point in there. And I should have mentioned that this is directional. So let me cancel out of this. I'll hit escape. We'll select the curves and go into analyze direction to check what direction the curves are. Because when it runs that script and it does that spacing, it's always starting at the beginning of the curve and going to the outer end. The other thing to know is that as it marches through the curves, it does them in the order that they were selected. Now, if you run that command and you manually click on each curve, it's going to build the mesh, assembling it from curve to curve to curve, and it'll do it in the order that you selected the curves. But that's a lot of curves to select manually. So the group selection is much nicer. And when you do a group select, such as dragging a window or typing a command like select curves, the order that it's going to use is the order in which those curves were created. So right now, because they were created from the contour command, They were created in order from 0, 0, marching down the x-axis in 1 meter increments. So they were created in this order. And since I haven't edited any of them, they're still in that order when I do a group select. If I were to split one of those curves and rejoin it or do some other destructive operation, it'll be considered a new object. So it'll get out of order from all of the others. So that's one thing to be aware of. When you run this script, you may want to do it right after you use the contour command to create all these things. Or if you were to run the contour command, there is an option to only create the contours over a certain range. So you can basically set a starting point and an ending point and give it a spacing, and it'll create contours just over that range and no further. If you don't give it a range, then it will create the curves to infinity in both directions. Because I could have given it a seed point at midships and a direction and a spacing, and it still would have done the entire length of the vessel because it's using that base point as the location for one of the curves, but it's not the starting point of the curve. It's just the location of a curve. If you specify a range, then you give it the starting point and the ending point for where it's going to make those cuts. So you could use the contour command still for having that control if you wanted to vary the spacing transversely, but you'd have to execute it multiple times. And that's why, if you had an irregular spacing, sometimes using those physical cutting planes can be useful. So that's another alternative there. So let's go ahead and run that script. We'll do load curves to mesh spacing. And we'll keep the 10% tolerance. And you'll just watch it'll take a few seconds as it creates all the points along these curves. It's basically pre-processing the curves right now. Now, the other thing, when you go to create using this method, the curves need to be continuous. So if your deck surface had openings in it for hatches, or if you're doing a bulkhead and there were doors in there, you would probably have to defeature the surface and close up those holes. And it's very easy to do in Rhino with similar to the trim command. You can right click and it'll untrim a surface. So you can click on a trimming edge in the surface that was used to create that hole, and it'll close it up. When I need to do that, what I'll typically do is I'll make a copy of the surface and I'll retain the original that has the openings in it, because you'll probably want those openings later for reference when you go to create the openings in the mesh. But for purposes of generating the mesh, sometimes I want to create the mesh without all of those openings in it. Now, this is if we use the script version, and the script also requires a uniform spacing. You can see we only had a single spacing available there. So it went from the center line all the way to the outer shell on 1 meter increments. There's no option to do 1 meters for the first 5 and then change the spacing. If you want to do that with the script, what you would have to do is create a cutting plane and then split the lines, similar to what we did with the hull curves, where we split the hull curves deck by deck. You would basically take all the curves that we created along the length and split them where we wanted to change the spacing, and you'd run the script twice. Once for the inner curves, once for the outer curves, and with different spacings. And you can see if we click on their mesh, there we go. So there's the mesh that was created. If we look, you can see how some of these lines aren't perfectly parallel to center line. This last segment, this is where that 10% tolerance came in. So we had 1 meter. If it used a 1 meter increment, it would have dropped a point there, but the last little segment was less than 10%. So it added it together and just created a single section there. So that's what the script will do. And having that constant girth can come in handy when you are creating the shell stringers along the length of the hull. As long as all of your transverse section cuts there are pointed upward, assuming you want to start your spacing from the deck moving up, it'll, as it marches forward, it'll add an additional stringer as the girth increases. So, and the resulting curves at the end here, you can see it has points, let me turn off the surfaces, replaces the original curve with a polyline. So basically, in the beginning, when there was that pause, it was taking all of the section curves and converting them into polylines with the appropriate spacing. And then afterwards, it went through and joined them all into meshes. It didn't destroy the original curves, it hid them. It put them in a group and then it hid them. So if you ever needed them back, you can do show selected and your curves are still there in a group. And these are the original single line curves. And then the new curves, if we were to delete this mesh, all of these new curves are polylines. If we turn on the points, you can see you have a node at each corresponding node in the mesh. So let me undo those commands for the script. And now we're back to the original curves, single segment here. And we'll use the contour method to generate the points here. And let me show you that range option on here, running contours. If before executing the command you were to click on this range button, it'll ask you for the range start point, and I'll do a partial set of points in here. So we'll run out to, this is about 7 meters off the center line according to the offsets at the bottom there. And we'll do 1 meter increments. And if I were to select curves again, and I'll start at, well, let me set the range and I'll start at that point and go out to 10. So that's about another 3 meters, but I'll use 0.75. So this is how you could create, a non-uniform spacing, but you have to do it in multiple steps. And you will notice that you wind up with 2 points there. And to get rid of those duplicates, you can simply use the select duplicate commands, which is SELDUP, and it'll grab all of those duplicate points and you can delete them. So now there's only 1 point at each of those locations. I'm going to select all these points, delete them, curves, on contour, select a point, pick the Y direction, and we'll do 1 meter increments. So now we have all of our points going out. Now you can see some of them are very close to the decking edge. So we don't necessarily want, these little sliver elements that are going to be created there. So in order to remove them, I'm going to grab the main deck, and for the time being, let me grab everything under the main deck, and I'm going to put it in a group and hide it. Now, I only put it in a group so that it's easier to select when I go to bring it back later. And now, since I only have the deck here, I can see exactly how close those points are to the decked edge. So on this outermost one, I'll delete the last 3 points there so that this one will run out a little bit. If I were to leave that point in, the next one in is going to be a tiny little sliver triangle here. So let me delete 2 there. And again, we'll do 2 more. 2 more. That's coming in at a steeper angle. We'll just do 1 back here. And up near the bow, we'll get rid of some of those closely spaced ones to give it a little bit more of a reasonable triangle for that last element there. We'll delete 2 here. This is coming in a little steeper, so we'll just delete 1. We'll delete that last one there too. So now I still need all of my points at the outer edge. So what we'll do is we'll select all those curves again. I know they run outboard, but we can check the direction anyway. We didn't want those curves there. We just want the points and the transverse curves. So we'll select all of these curves. We know they run inboard to outboard. So then we can use that curve point object, mark curve ends. So we mark the curve end, and now we have a point on the decketed edge. At the bow, we still need a little bit more. But before we do that, let's go ahead and we'll select all of these points with select points, SELPT. Once we have all the points selected, under the Mesh Tools menu, there is an option on this toolbar on the left here called Mesh Patch. And what that will do is create a triangular mesh from all of the selected points. So we click that command and it asks for, I just use the defaults for all of these, the angular tolerance and starting surface, but you can see it creates a mesh of triangles from all of those points. Once you have them created, there is an option on the upper toolbar for quadrangulate mesh. And you can see this will be what's highlighted is the remaining final result mesh, and the black lines are all the ones that are going to be removed. Typically just use the defaults here. But you can see now we have a fairly nice mesh in there. Now we're missing a couple up at the bow. We're missing a couple at the stern because we didn't have a last section cut there. And you can see, well, here's a quad that's broken into two tries that we probably want to merge. Well, they have some very nice tools in here for manipulating the meshes. So we can simply say merge two mesh faces here, and you click on that line that's dividing them, and it merges them into a single face. The others all look like they got converted into triangles at the end as we wanted. So we're in pretty good shape there. But we're still missing points at the bow and stern. So let's delete that mesh, and we'll add a couple extra points here. So we'll go into the standard menu, and we can create a single point. From our object snaps, we still have end and intersect in there. So it's going to grab the both end and intersection, and it's looking at the curves on the boundary of the surface here. The smart track, as they call it, which is you can turn it on and off here. But when you hover on a point and then move away from it, it'll want to do an extension, and you can find the apparent intersection with that edge of the surface and drop a point right there. So I didn't have to go and create a section curve or anything. You can just very quickly drop the point using that smart track. And similar at the other end, I'll create an additional point at the corner, which I know we need. And I could do that smart track option to get the intersection at the aft end for all of these. But I know that it's a flat deck, and I know the transom is square at the end there. So we can just copy all of those points from the line closest to it, and we'll move them from that line to top of the transom. And now we have all the points that we need. So we can select points, go into the mesh menu, say mesh patch, and then quadrangulate that. And now we have our deck mesh. Points and delete them. And if we turn off the surfaces, you can see there is our mesh. Now, if we didn't want to do contours, another method of getting those, and this is similar to the girth method that's used on that script. If you didn't want to use and actually generate the mesh, if you only wanted the points, a similar way of getting it would be to go into the curve point object, and previously we used the number of segments, but if we were to use length of segments and specified 1 meter, you can see we got a very similar collection of points to what we did with the 1 meter contours. Now we deleted a few at the ends there. You can see which ones were missing, but that would be another way to create those. Now, the nice thing about doing it that way is you're not limited to a series of planes that are parallel to one another. It's doing a girth along the curve. Now for a deck or a bulkhead, it's not so much of an issue. But when you're dealing with the curved surface of the hull, and you may want to do a girth along the curve rather than an even height increment, which is what you'd get if you did the contours. So that's a nice option there for generating those curves on the hull, and that's what we'll use when we do the hull portion.